looking at the test review for topic 2, question number 1 asks the question, based on this pattern, what are the next 2 terms in the sequence going to be? All right, so it gives us the first 4 terms in this sequence, and we have to find the 5th and 6th term, the next 2 that come after it. So when I look at those numbers going right there, going from 2 to 6, there are 2 different ways you could get that. You could either be adding 4, 2 plus 4 gives you 6, or you could be multiplying times 3. The previous number 2 times 3 gives you that 6. Well, when I look at the next set of terms, 6 to 18, it's pretty obvious that our pattern is that you always take the previous number and you multiply it times 3. So that's exactly what we're going to do to find the next terms. Okay? If we're looking for the next terms that come after it, we go 2 to 6 to 18 to 54, and we got to take 54 and multiply it times 3. 54 times 3 gives us our next term, 162. And then you multiply that one times 3 to get the next one, and that'll be 486. All right, that's our next 2 terms in that sequence. Look at question number 2. It's asking the same thing. Okay, it's asking the same thing. What are the next terms in the sequence? So when we talk about this, we can see that every other number is switching between positive and negative. So that means the number that we're multiplying times to go from one term to the next is a negative number. Okay, so we know that our next number has to be positive. And as we look at the values of all these terms, we go from 3 to 6, not thinking about the positive and negative, just looking at the numbers themselves. 3 going to 6 is multiplying times 2. 6 going to 12 is times 2. 12 to 24 is times 2. So our next term is going to be a positive number, we already know, and it's going to be twice as large as 24. So it's going to be positive 48. Next thing we're looking at is that same thing. We got to multiply 48 times 2 and we get 96. And so our next term has to be negative, so it's going to be negative 96. On number 3, the numbers are actually getting a little bit smaller. So we're not going to be multiplying times something, we're going to be dividing by something every time. And when I look at that, we go 75 to 25. Well, that's dividing by 3. 25 to 8 1/3, that's dividing by 3 again. And so when we divide that 8 1/3 by 3, punching that into a calculator, we get 2.777 repeating. Well, 2.777 repeating, according to my calculator, is 2 7/9. So you can just leave it as 2.77, all repeating, just like that. Our next one, we divide by 3 again, and we get 0.925 repeating. 925 is what repeats this time, that pattern over and over again. That's 25 over 27. That's the next term that comes in that sequence. All right, so number 4. Number 4 is where it gets a little more interesting. Okay, number 4 asks, what is a counterexample for the conjecture? Okay, and first we got to know what that word counterexample means. Okay, a counterexample is something that by its existence, it disproves a statement. Okay, so if I put forth the statement and I said, if you are a girl, then you have long hair. Well, you could disprove that statement pretty easily by showing me a girl who doesn't have long hair. That girl would be a counterexample that disproves that statement. Okay, so when we have this statement, any number divisible by 3 is an odd number. If we're trying to disprove that statement, all we have to have is a number that is divisible by 3, but it's not an odd number. Okay, that's a counterexample that would show that statement is wrong. And so there's a pretty easy one that comes to mind right off the bat, and that's the number 30. Y'all, 30 is of course divisible by 3. It's 3 times 10. But it's also an even number. So it is divisible by 3, but it doesn't fit into that statement. It is a counterexample that shows that statement is false. All right, going on to the next one. Number 5 is asking about the converse, inverse, and contrapositive. Okay? The converse, inverse, and contrapositive of a statement. So we have to remember, and this would be a good thing that you could fill out on your cheat sheet, you need to know what those things are. You need to know the difference between the converse, inverse, and contrapositive. So when I look at this statement, if a point is in the first quadrant, then its coordinates are positive. Okay? That is a combination of two separate statements. The two statements, the two parts of that sentence are points in the first quadrant, and the second part of that statement is the coordinates are positive. Okay? And what it's saying is if a point is in the first quadrant, that first part implies the second part. So if we were to take the converse of that, according to our notes, the converse of a statement is when you take that statement and you swap it around backwards. Okay? We're exchanging the hypothesis and the conclusion. So the converse would have all of that same information, except the second part would come first. All right, so I'm going to zoom in real close here, and hopefully y'all will be able to follow along, okay? The converse is this. The converse takes that statement and it swaps it around backwards, okay? We're going to say if the coordinates of a point are positive, then it is in the first quadrant. If the coordinates are positive, the point is in the first quadrant. All right, so that's the converse. You just take those two parts of the statement and you swap them around. The inverse is where you take that original statement and you just say the opposite of it. Okay, so you don't swap anything around. Okay, the stuff about the first quadrant is still going to be the first part of the statement. The stuff about the positive is still good. The stuff about the coordinates is still going to be the second part of the statement, except you're going to say the opposite of both of those things. Okay, so the original statement said if the point is in the first quadrant, then the coordinates are positive. Well, we're going to say for the inverse, we're going to swap that around. We're going to say if the point is not in the first quadrant, then the coordinates are not positive. Oh my goodness. Coordinates not positive. Now the last one, the contrapositive, is the one that combines both of these things, okay? The converse swaps around your information, the inverse negates your information, and the contrapositive does both, okay? So for the contrapositive, we have to take the opposite of both of those things and swap them around. Well, what we're doing is we're taking the inverse and we're swapping it around, okay? So for the contrapositive, and I apologize that my normal pen is not working today. For the contrapositive, we're going to say if the coordinates are not positive, then the point is not in the first quadrant. Okay, so the converse swaps your information around. The inverse negates your information but doesn't swap it around. The contrapositive does both. All right, let's look at our number 6. Number 6, write the proof. Given that those two angles are complementary, prove that x equals 28. So this is a great problem that all of the math part of this answer is already finished. The entire left column right there is the math part. All we have to do is write down the reason for those math parts. Okay? So on your test, it's actually going to be even easier than this. On the test on Canvas, there's going to be, it's all multiple choice. There's going to be a selection of things for you to pick that you can fill into these blanks. It's just like your homework problems. All right, so let's start with statement number 1. The two angles are complementary. Well, where do we see statement number 1? How do we know that's true? It's given to us. Right up here, up above, it already said those two angles are complementary. So we know this is true because it's given. Okay, that one's given. Now, when we go from number 1 to number 2, we're not actually changing any information. Statement number 1 to statement number 2, the only thing we're doing is we're changing that statement into math stuff. Okay, so when we say those two angles are complementary, that just means when you add those angles together, you get 90 degrees. Well, that's what statement number 2 says. All we did was we used the definition of complementary. All we did was we used the definition of complementary. What that word means tells us those two angles add together to get 90. Now, when we go from number 2 to number 3, what we did was we tossed out all that geometry stuff. Okay, what we did is we swapped out all that geometry stuff and we turned it into algebra stuff. And that algebra stuff, the 2x plus x plus 6, that all came from this picture. Okay, the 2x is right there. The x plus 6 is right there. It's not a total mystery where those things came from. But what we did was we took out the geometry symbols and we replaced them with algebra symbols. Okay, and what we did right there is substituted the information that was given to us. All right, that was substitution. Going from number 3 to number 4, you'll notice that the right side of that equation did not change at all. Okay? Nothing changed about the right side. But on the left side, 2x plus x turned into 3x. Y'all, that's just combining like terms. Number 5. Going from number 4 to number 5, we lost a 6. On the left side, we lost that plus 6, and the right side of the equation dropped by 6. So what we did, we subtracted. We used the subtraction property. Subtraction property. And then going from 5 to 6, we divided both sides by 3. So we were using the division property. Take a look at number 7. Number 7 is given that the whole thing, GFI, is 128 degrees. It's asking us to prove that EFI equals 40. All right? So, we start with the information that's given. I tell you what, go ahead and skip this problem. Go ahead and skip this problem. Don't worry about number 7 on your review. Skip on down to number 8, where we're just filling in those blanks right there. All right? This one tells us we had this, I think we had this exact problem on the practice the other day that we did together. Measure of ABC is 80 degrees. All right? It tells us from angle addition that you can add those two smaller angles together and get the larger one. And substitution, we swap out all of the geometric terms in that equation and we turn it into an algebra problem. Okay, we swapped out the geometry for the algebra. Okay, that was substitution. Going from this step here to this step here, all we did was we took 3x and 6x and put them together and became 9x. We took plus 3 and plus 5, we put them together, it became plus 8. All we did was we combined like terms. Going to the next step from A to B, you can see that we lost an 8. We lost a plus 8 on the left side, and 80 turned into 72 on the right side. Y'all, we subtracted that out of there. It was the subtraction property. Going from B to C, we lost the 9 on the front. What we were doing when we were solving that problem was we were taking it and we divided that 9 on both sides. We used the division property. Go ahead and skip number 9 as well. Okay, everything on your test, you're going to be proving it just like the homework problems. You're not going to be filling out the entire proof yourself. You're going to be filling in blanks. All right, it's going to be like problem number 10 right here. All right, problem number 10 looks like this. All right, we start off with the fact that xy equals 42. That's a given statement. Going from... So the question is, on that second line, how do we know that that is true? I guess, first of all, what is that statement saying on the left side next to blank A? Well, that statement is saying that the two chunks of this segment, when you add together xz, that chunk, plus zy plus that chunk, it equals the length of the whole thing. Y'all, that is just a restatement of the segment addition postulate. That's just from what we know about segment addition. Now, going from A to B, you can see that we don't have any more geometry stuff listed in that equation anymore. Okay, xz turned into 3 times n plus 4. zy turned into 3n. Okay, we swapped out the geometry stuff and we put in the algebra stuff. That is the substitution. That is substitution right there. Going from B to C. Most of that equation didn't change except the 3 times n plus 4 on the left. That turned into 3n plus 12. Okay, what we did was we distributed that 3 into those parentheses to get rid of them. So we used the distributive property of math. Up next, you can see going from C to D, we turn that 3n on right. We turn the 3n right there and the 3n right there. We put those together into 6n. So all we did was combine like terms. Going from D to E, we lost a plus 12 on the left. 42 turned into 30 on the right side. So we subtracted. We used the subtraction property. And going from E to F, 6n becomes n, 30 becomes 5. We use the division property. Going on to this set of problems right over here. All right, it asks us to write an example of each property. Now this right here is something that would be very good to put onto your cheat sheet. Okay, this would be a great thing to put onto your cheat sheet. All right, the transitive property. The transitive property says this. If A equals B, okay, and we're just using general letters. We're general letters. Any number that you substitute into this could fit. All right. So you could say if A equals B and B equals C, if you have both of those pieces of information, then that also means that A equals C. So the example that was on your notes said that if 3 times 3 equals 9, and 9 also equals 4 plus 5, then you could take both of those pieces of information and say that 3 times 3 equals 4 plus 5. And we know that's true, but this is just the formal way of writing down. This is the name of that property that says that's true. All right? Up next is the reflexive property. The good way to remember the reflexive property is that it is exactly the same on both sides, just like a reflection in the mirror. Y'all, the reflexive property says, for example, A plus B equals A plus B. You have exactly the same thing on both sides of that equal sign, just like the reflection in a mirror, the reflexive property. Okay? Another example that was in those notes. It just said that 4 equals 4. All right, up next, the substitution property. Substitution property is what it looks like when you can, so the substitution property says if A equals B, then A can be replaced by B. Okay, so think about this example that was in your notes. We can say that X equals 5. If we already know that X equals 5, and we needed to find what 2X plus 1, okay? then that substitution says we can take 2x plus 1 and we can change that into 2 times 5 plus 1. We're taking out the x and replacing it with that number 5. That's what substitution looks like. Okay? Most of the time in the proofs that we work, it's like this stuff up here. We're taking out the geometry stuff. We're taking out this geometry stuff and we turn it into the algebra stuff. Okay, we replace it with the algebra stuff. That's usually what substitution looks like in our proofs. Up next is the symmetric property. Okay, and the symmetric property just says that an equal sign is the same no matter how you write it, no matter how you write things down on either side of it. So, like you can say that 4 plus 5 equals 9. And that's true. Well, you could also say 9 equals 4 plus 5. And that is still true. Okay? The symmetric property is it's a property of equality. And that tells us if A equals B, like that, you could say B equals A, and that's still the same statement. And it doesn't change anything. All right, that's what the symmetric property says. Last thing is the distributive property. Distributive property of something is something that you learned about way back in probably 7th grade, somewhere around there. Okay, the distributive property is what you use. That's how we know that 3 times x plus 1 is the same thing as 3x plus 3. Okay, the distributive property tells us that you take that 3 and you multiply it times everything inside of those parentheses. All right, that's what the distributive property looks like. So these last couple of questions here are just asking us about these pictures. All right, in these pictures, it asks us what is the value of x. So what we've got here is 2 straight lines that cross each other right there and right there. 2 straight lines across each other, and we're looking at 2 angles that are on opposite sides of those straight lines. Y'all, those are vertical angles. And the vertical angles theorem from way on back in section 2-6, the vertical angles theorem said that those 2 angles are congruent to each other. They are the same size. And since they're the same size, that means these 2 measurements are equal to each other. So we can take 15x minus 63 and say that that is equal to 7x plus 9. After that, all we're doing is just solving this equation, finding x. That's what the question is asking for. The question is asking, what is the value of x? We just have to solve this equation. All right, so I move all of my x's over and make sure that all the x's are on the same side over here. You do like that. That goes away. We've got 8x minus 63 equals 9. And then what am I going to do? Well, I'm just going to send the friends home first. I'm going to send the friends home first. Plus 63. So 8x is equal to 72. And then I can divide that, send the family members home, and we'll get that x equals 9. By the way, if we were trying to prove that x equals 9, we could just say that those 2 things, those 2 expressions right there, are equal because of the vertical angles theorem. And then we could say that with the addition property of equality, 8x equals 72, and then the division property of equality says that x equals 9. All right, this last one, coming on down here. The measure of angle 3 is 36 degrees. This one right here, 36 degrees. It's asking us to find the other 3 angles. Well, one of those without doing any calculations, without doing any actual math, punching anything in the calculator, we already know that the vertical angles theorem says that the one that's opposite of number 3 is also going to be 36. So that's going to be number 1. The measure of angle 1 is going to be 36 degrees. We know that one just right off the bat. The next question is, what's the deal with the other two? Okay, so we need to know what's going on with angle 2 and angle 4 right there. Okay, so here's what I'm thinking. When you put angle 2 and angle 3 together, they come together and they form this straight line that goes across right there. Angle 2 and angle 3. Okay, think about that for a second. Angle 2 goes like that. Angle 3 goes like that. When you put them together, you end up with this one big old straight line that goes across just like that. Just like that. Okay? So we know in a straight line, there's 180 degrees is what represents that. So if we take this knowledge that the whole thing, angle 2 plus angle 3, is 180. Well, we already know what angle 3 is. So whatever measure of angle 2 is, plus that 36 degrees is 180. All we got to do is subtract 180 minus 36. We're just looking for the difference. So what's going to go right here? 180 minus 36. And all you got to do is punch that into the calculator. And you can see that angle 2 is 144 degrees. 144 degrees. Y'all, angle 2 and angle 4 are vertical angles. And that means they are congruent. That's the vertical angles theorem. Says when you have vertical angles and you know the measure of one, you already know the measure of the other one. It's the same. So that tells us that angle 4 is also 144. All right. Angle 2, angle 4, and there's angle 1 right there. All right, that's the answers we were looking for. 36, 144, and 144. All right. If you're working on this at home and you have questions, please come into tutorials and let me know. Okay, that's what I'm here for. All right, I'm going to post this video, and I'm going to post the key that came. I'm going to post this PDF also. Or I'll post a PDF of the answer key also. All right, so do your best on it, and don't forget about your cheat sheet. And I will see you all tomorrow.